started the unit number 5. Yes. In that, first of all, we have seen some basic concept related to the vector, right? That is how to take the dot product, cross product. Then we have seen the tangent vector, that is dr bar upon dt. After that, the normal vector, that is del phi. After that, we have seen the very important topic, that is the directional derivative. Hmm? Directional derivative, that is the derivative along the arbitrary direction of vector, that is the directional derivative, correct? After that, we have seen some properties of directional derivative. Now in this lecture we are going to start the next point, that is the irrotational and the scalar potential pi. Irrotational vector field, that's then solenoidal vector field. These are the topic of our today's lecture. So let me share the screen my screen of today's PDF with you. Okay, so just go through the definitions of, first of all, divergence. In this lecture, we are going to see divergence, then curl of a vector, and by using this, we are going to see the concept of the solenoidal and irrotational vector field. Okay, so divergence of a vector. Divergence that measures the magnitude of the vector field. Okay, what this quantity represent? That represent the magnitude of the vector field. For example, suppose if you are having this as a vector f bar equals to f1 I bar plus f2 j bar plus f3 k bar, then divergence of f bar is given by del dot f bar. Okay, and del dot f bar, that is equals to, it is, we know the definition of del, that is I bar dabba upon dabba x plus j bar dabba upon dabba y plus k bar dabba upon dabba z. That is the definition of del dot f bar. So let us take its dot product. Dot product of these two vector means we'll have to multiply the scalar component of I bar, then the scalar component of j bar, and the scalar component of k bar. So it will be what? Here the scalar component is dabba by dabba x. Here it is f1, means it is dabba f1 by dabba x. Then here it is dabba by dabba y, into it is f2, means dabba f2 by dabba y, and dabba by dabba z of f3, that is dabba f3 by dabba z. So in this way we can find the divergence of vector field f bar. Okay. So remember del dot f bar. Now each and every time in solving the example, we are not going to write these vectors and their dot product. What we'll do, we'll just remember this del dot f bar, which is f1 by x plus f2 by y plus f3 by z. So it is the divergence of the vector field f bar. Now move toward the next point, that is the curl of the vector field f bar. The curl of the vector field measures the tendency for the vector field to swirl around, means the circular movement. Swirl around, that is the circular movement, that is the rotation. Means curl, that quantity measures what? Measures the tendency for the vector field to swirl around. Means we can find the rotation of the vector field by finding the curl. Now let us see how to find out that curl. Curl of f bar is given by del cross f bar. Now you know very well how to take the cross product of any two vector. We are having the two vectors here, del and f bar. So cross product is given by the determinant of, as the first row of the determinant I bar, j bar, k bar. Second row, the scalar component of del, that is dabba by dabba x, dabba by dabba y, and dabba by dabba z. And the third row, scalar component of f bar, that is f1, f2, f3. So after solving, evaluating the value of determinant, you can find the curl of the vector f bar. So remember these two important points. When they ask you to find divergence, means remember you will have to find del dot f bar, and when they ask you to find out the curl, you will have to find del cross f bar. Okay, so is it clear about both the points? For any difficulty, you can type your difficulty in your chat box. I will give the answer to that. Yes, any difficulty, any doubt? Okay, whether the both the points are clear to all of you? Yes, is it clear both the points? Okay, good. Yes, I think most of the students have clear about these 2 points. Okay, so we'll just move toward the next, that is the note. Hmm, to see. Okay, so note the point. If del dot f bar equals to 0, hmm, then f bar is said to be the solenoidal. When del dot f bar is equal to 0, okay, then f bar is said to be solenoidal. It is also called as the solenoidal, means the incompressible vector field or a divergence free vector field. So this is a property. Remember, if del dot f bar equals to 0, then the field is said to be the solenoidal. Solenoidal, that is the incompressible. So in solving the example, you will be having the vector field f bar, and you will have to check whether the field is solenoidal or not. So for that, you will have to take the dot product of del and f bar. Okay. If it is 0, then we can call the field as a solenoidal, that is incompressible or the divergence free vector field. Now come to the second point. If del cross f bar equal to 0, then the field vector field f bar is said to be the irrotational or conservative vector field. See, del cross f bar, what this represent? Curl. Curl, that is the rotation. So if the rotations are 0, means it is said to be the irrotational or the conservative field. That is the second point. Means remember, whenever we have to prove that f bar is irrotational, in that case we have to prove that del cross f bar equals to 0. Is it clear? Now the third point, if f bar is irrotational or conservative, okay, if it is irrotational, means there exists some scalar potential. Okay, there exists some scalar potential phi, and it is given by. It is true only when the field is irrotational. Irrotational means there is some energy, there is some scalar potential, phi is there. Okay, and that phi is given by this formula. Integration f1 dx, here yz as a constant you will have to treat. Okay, f1, just compare the given f bar with f1 I bar plus f2 j bar plus f3 k bar, you will get f1. Then substitute here f2, not complete f2. See, here you will have to treat z as a constant, and you will have to put such a value from f2 which is free from x. Is it clear? Do not put the complete value as it is f2 here. We'll collect such a term from f2 which are free from x, and the same way here integration f3 dz, but collect such a terms from f3 which is free from x and y both. In this way you will get the value of phi, that is the scalar potential. Okay, we'll see this in detail, how to use this formula in solving the example. Okay, it will be more clear when we solve the actual example. So first of all, just recall the point. Solenoidal, that is del dot f bar equal to 0. Irrotational, that is del cross f bar equal to 0. And if it is irrotational, you can find phi by using this formula. Okay. So now let us start the examples. First example, prove that f bar equals to x I bar plus y j bar upon x square plus y square is solenoidal. Hmm. So this is your f bar. Just separate out the denominator. What I have done here is just separate the denominator, x upon x square plus y square, and here y upon x square plus y square. Just separate the denominator. I have written this f bar. Now we have to prove that it is solenoidal. So we know that when the vector field is solenoidal, when del dot f bar equal to 0, when it is divergence free. Divergence free, that is the incompressible vector field, then it is said to be the solenoidal vector field. So for that, let us calculate the value of del dot f bar. Del dot f bar is what? Da by f1 by da by x plus da by f2 by da by y is the value of del dot f bar. Okay. So substitute here f1. Just compare this with f1 I bar plus f2 j bar. Substitute the values of f1 and f2 there. Here I have substituted f1 and here I have substituted the value of f2. Okay. Now let us differentiate here. Differentiate with respect to x. Now you can see x is there to the numerator and to the denominator. Means we'll have to apply the u upon v rule for the differentiation. Quotient rule for the differentiation. So see, denominator x square plus y square as it is. Numerator its derivative is 1. Denominator its derivative, numerator as it is, and denominator its derivative is 2x. With respect to x, y is a constant, and denominator v square means x square plus y square bracket square, plus with respect to y. So see, denominator as it is, numerator its derivative 1. With respect to y we are differentiating. Now numerator as it is and denominator its derivative with respect to y, that is the 2y upon denominator's square. Okay, we have just taken the derivatives. Now just simply add these. Numerator means take the common denominator as x square plus y square bracket square. Add the corresponding numerator, x square plus y square minus 2x square plus x square plus y square, and it is minus 2y square. So all the term will get cancelled here. X square plus x square with minus 2x square, and y square plus y square minus 2 and plus 2y square cancel. In this way, del dot f bar equals to 0, and hence f bar is the solenoidal vector field. So this proves the result that the given vector field f bar is solenoidal. Okay. Is it clear, the example number 1? Any difficulty? Any doubt? Can we move toward the second example? Okay. How 0, sir? Sir, all the terms are getting cancelled. No? You can see here x square means 2x square will get cancelled with minus 2x square. Y square, 2y square plus 2y square minus 2y square cancel. 0. Yes. So that's why it is 0. Yes. Any more questions? Okay. So let us move toward the next. Second example. Example number 2, show that f bar equals to 6xy plus z cube I bar plus 3x square minus z j bar plus 3xz square minus y k bar is irrotational, and find scalar potential phi such that f bar equals to del phi. So in this example, we have to prove that f bar is irrotational. We know that when the vector field is irrotational, when del cross f bar equals to 0, then the vector field is irrotational. And once you get the irrotational vector, we can find the scalar potential phi. So for that, let us consider del cross f bar. See, I have written again here f bar. Now del cross f bar, all of you know very well how to take the cross product of the two vector. Hmm? So del cross f bar it is given by the determinant, the first row I bar, j bar, k bar. In the second row, dabba bar dabba x, dabba upon dabba y, dabba upon dabba z. And in the third row, it is f1, f2, f3. Okay. So now just compare the given f bar with f1 I bar plus f2 j bar plus f3 k bar and substitute these values here, values of f1, f2, f3. Hmm. Substitute that value. Now evaluate the value of determinant. Hmm. See this I bar, skip this part, dabba upon dabba y minus dabba upon dabba z of this. Then minus j bar, then dabba upon dabba x minus dabba upon dabba z of this. Plus k bar, dabba upon dabba x minus dabba upon dabba y of this. Okay. Let's evaluate the determinant now. See, with respect to y, derivative of this underlying term will be minus 1. Is it clear? With respect to y, xz is a constant. So derivative of this 3xz square will be 0. Minus y will be minus 1. Now here with respect to z will be minus 1 because derivative of 3x square is equals to 0. Is it clear? 3x square will be 0. Minus z will be minus 1. Now minus j bar with respect to x of this underlying term, with respect to x, so x will be 1. What is remaining here? 3z square and the derivative of this minus y 0. With respect to z of this underlying term now, this underlying term 6xy will be 0, z cube will be 3z square. Next, with respect to x of this underlying term 6x minus z will be 0, and with respect to y of this underlying term will be 6x, z cube will be 0. And hence you can see here minus 1 minus minus plus 1 is 0 0, and hence del cross f bar equals to 0, and hence this implies goes to that f bar is the irrotational vector field. Is it clear up to this? We have just calculated del cross f bar, and we have we have got the value of del cross f bar as equals to 0. So therefore f bar is irrotational. Now once you get irrotational vector field, we'll have to find the scalar potential. Hmm, Scalar potential phi. So for phi, this is the formula: integration f1 dx plus integration f2 dy plus f3 dz. Here we'll put f1 as it is. By keeping yz constant, we'll integrate. Now from f2, we'll not put the value of f2 as it is here now. We'll put such a value which are free from x, and f3 free from x and y. Okay. So see, f1 that is this. Just compare this with f1 hyper. So the value of f1 I have substituted here as it is. Now you can see here the value of f2. F2 contain two terms. One is 3x square and another term is minus 8. So 3x square containing x, so neglect the term. So what is remaining here? Minus z only. So that term only you will have to write here. Means you have to write here such a term which is free from x. Then f3. Collect such a term from f3 which are free from x and y both. So there are two terms and both the terms containing x and y. That's why it is the integration of 0 dz. Okay. And now integrate the term with respect to x. Each of this term we have to integrate. So x, its integration x square by 2. Z cube will be z cube x minus z, its integration with respect to y, that is minus zy plus c. Okay. So this is the scalar potential phi. So this complete the answer. We have proved that f bar is irrotational, and hence we have find the scalar potential phi. Any difficulty in this example? Can we move toward the next example? Yes. Okay, so it is start. the next example. Now examples are of similar type. Similar type of examples are there. Again, in this example, we have to show that this f bar is conservative and find the scalar phi, hmm, such that f bar equal to del phi. This is always true. This property is always true when the vector field is irrotational or the conservative. Hmm. Same meaning is same. Irrotational, that is the conservative. Hmm. So now, first of all, see, this is your f bar. We'll evaluate now first of all the value of del cross f bar. Del cross f bar, that is ijk, dabba x, dabba y, dabba z, then f1, f2, f3. Substitute here now f1, f2 and f3. Just compare the given f bar with f1 I bar plus f2 j bar plus f3 k bar. Okay, I've just substituted the values. Now evaluate the value of determinant I bar, dabba by dabba y of this, dabba by dabba z of this. Minus j bar, so skip this term. This dabba by dabba x of this, dabba by dabba z of this. K bar, skip this term. Dabba by dabba x of 2y sin x minus dabba upon dabba y of y square cos x plus z square. Hmm? Now just go through the derivatives. Just go through the derivatives. Let's just go through the derivatives. Okay. So see, dabba upon dabba x of dabba upon dabba y of 2xz. Y is not there, so that's why derivative 0. Dabba upon dabba z of this term. Again, z is not there, means derivative 0. Next term. Dabba upon dabba x of this term, this x will be 1, so it is 2z. And with respect to z of this term, so see y square cos x will be 0 and the z square will be 2z. Okay. The third term, with respect to x of this, 2y sin x will be the cos x. Hmm? With respect to y of this y square will be 2y cos x and z square will be 0. Hmm? And hence you can see all the term are getting cancelled and hence the del cross f bar, its value is equals to 0. And hence f bar is irrotational or the conservative. Now we'll find the scalar potential phi, which is given by integration f1 dx plus f2 dy plus f3 dz. Here free x and here free x and y. So substitute the value of f1 as it is. What is your f1? Y square cos x plus z square is your f1. So substitute that value as it is here. Now f2. Collect such a term from f2 which are free from x. f2 contain only one term, that is 2y sin x, which contain x. So neglect the complete term. Okay. And f3. Again from f3 we have to collect such a term free from x and y both contain only one term which contain x. So neglect the term, that is integration 0. Now this is the term y square cos x. We have to integrate with respect to x. So cos x, its integration, that is sin x. Z square, its integration, z square x plus c. Okay. So this is the scalar potential phi. Is it clear? Is it clear the example number 3 to all of you? Okay. So now let us move toward the next example. Yes, example number 4. Okay. Again, it is of very similar type. Verify whether following field is irrotational. If so, find corresponding pi. F bar is given. We have to find whether it is irrotational. Means again we are going to find here del cross F bar. Write the definition. Substitute here the values of F1, F2, F3. So see, I have substituted here F1, here F2, and here F3. Substitute the values. Now again, just go through the derivatives. Let's go through the derivatives, all of you. Yes, we're going through the derivatives. Hmm. So see, with respect to x, yes, it's very simple. Dabba upon dabba of this minus dabba upon dabba z of this. So say with respect to y, derivative of this term will be, it is x cos z. This how y1 will x cos z, and this y square will be 2y. So x cos z plus 2y. When you differentiate this underlying term with respect to z, so it will be x sin z will be x cos z, right? Sin z will be cos z because we are differentiating with respect to z. Now here 2yz is there, so this z will be 1. So it is remainder 2y. Similarly here with respect to x, so it is y cos z. With respect to z, so it is y cos z. Sin x will be 0 because again differentiation with respect to z. Same thing here with respect to x will be sin z. Sin z will be there, x will be 1, and this 2yz will be 0. Now with respect to y of this term will be sin z, right? And sin x will be 0. All the terms are getting cancelled, and hence del cross f bar equals to 0. This implies goes to f bar is irrotational. Again write the formula for phi in the same manner. Okay, I have not written the further solution here. Can you simplify this part? Just substitute here the values. Yes, please simplify and type your answer in chat box fast. I have not simplified further part. See, F1, put F1 as it is. Hmm? F1 as it is, that is this term as it is, integrate with respect to x. F2 free from x. Free from x, so you will have to neglect x and z and take only 2yz and its integration with respect to y. F3, yes, Trupti has given the answer xy sin z minus cos x y square z plus c, correct? Yes. And F3 free from x and y, so neglect both the term. Yes, please calculate the answer. Yes, Keshav Agrawal has also given the answer. Yes, please solve and type your answer in chat box. Yes, solve it fast. F1 as it is, you have to put there yz constant. From F2, it is 2yz, which is the term free from x, and in F3 there is no term free from x and y, so that term will be 0. Yes, Rutuja Deshmukh also given the correct answer. Xy sin z minus sin x will be cos x. We have to integrate. Yes, Roshan Wag also given the correct answer. Yes, Yutik. Yes, correct answer. Yes, Abhishek Wag. Yes, correct answer. So let me tell you the answer. See, the first we have to integrate with respect to x. Simple. X, y, z, psi sin z will be constant, so its integration will be what? X, y, sin z, right? And integration minus will be there, and sin x its integration, okay, sin x that you have to integrate, that is the minus cos x, so that minus minus become plus cos x. Now this term we have neglected, and this is the term we have to integrate, so it is y will be y square by 2, 2 to cancel, so it is what? Y square z plus c. Okay, all of you get the same answer. Yes, all of you get the same answer. Okay, so let us move toward the next last example. Yes, I think all I have the same answer. So let us move toward the next example. Okay. See, in this example, it is of a different type. In this example, they are already given. If vector F bar is irrotational, means they are already given that vector field is irrotational, and we have to identify, determine the value of ABC, and then we'll find the value of phi. So as F bar is irrotational, we'll use the property that del cross F bar equal to 0. Del cross F bar, that is the determinant of ijk, dabba x, dabba y, dabba z. F1, F2, it is F3. F3 equals to 0. So substitute here F1, F2, F3. Hmm? Substitute the values of F1, F2, F3. Again, evaluate the value of determinant. Take the derivatives here. Can you take the derivatives? Yes. It's very simple. With respect to y, derivative c. With respect to z, derivative is -1 here. With respect to x, it is 4. With respect to z, it is a. With respect to x, b. And with respect to y, it is 2. Okay, so just take the derivatives. You will get this. Now the right hand side is 0. So we'll write that 0 as a 0 I bar plus 0 j bar plus 0 k bar. Equate the coefficient of I bar, j bar, k bar. You will get c equal to -1, a equal to 4, and b equal to 2. Okay, are the values of ABC. So now use this value ABC in the given F bar. Hmm? Use the value and again find the scalar potential phi. Again the same formula. Hmm? F2 free from x, F3 free from x and y. Integrate the term here with respect to x, y, and here with respect to z. You will get the required answer. Okay. So now whether the topic is clear to all of you, today's topic. Yes. Whether today's topic is clear to all of you. Again, one compulsory example in exam will be there. Okay, on irrotational that one on direct derivative, another will be on irrotational. Okay, that the compulsory topic as the exam this topic. Okay. In the next lecture, we'll start our next topic, that is the vector identity. Okay, according to your timetable, it is already shared with you. So in that lecture, we'll have the topic vector identity. Okay, for any difficulty, Any doubt you can ask me by call, by WhatsApp. Okay, just complete your notes and clear your doubts. Okay, all of you, please complete your notebook. Okay, so now I will end up with this meeting. Okay, thank you all.